Right, let's have a look here. This one. So firstly, want to get the root here. So by expanding, p squared plus 2pqi minus q squared equals 5 plus 12i. So we have p squared minus q squared equals 5, and then pq equals 6. So that means p equals 6 over q. Sub that in. So that means 36 over q squared minus q squared equals 5, multiplying by q squared. Taking everything to the right. And then solving that quadratic. 9 and 4. Yeah, that works, doesn't it? This one doesn't make sense. So you have q equals plus or minus 2, which means p is plus or minus 3. So it's 2 plus 3i or minus 2 minus 3i. And I can test it. Oh, I think I made a sign mistake. I'm getting minus 5. Oh, did I mix up my P's and Q's? Yes, I did. 3 plus 2i and minus 3 minus 2i. Okay, now it's right. Okay, part 2. We want the modulus here. Alright, so modulus of z will be the modulus of this, and I should rationalize here. So I'll multiply above and below by 1 plus I tan theta. So that's going to be the modulus of 1 plus I tan theta plus I tan theta minus tan squared theta all over 1 plus tan squared theta. So that's the modulus of 1 plus 2i tan theta minus tan squared theta over 1 plus tan squared theta. No, I don't think that's right. I think what I should do is use a bit of trig rules to simplify that expression before I try to get the modulus. I don't even think I should rationalize by multiplying by the conjugate. Let me open up the formula book and we'll have a look at the formulas now together. Oh, I just realized in my last video when I was sharing my web browser, you couldn't see it. Oh well. I have the formula book up here, but you can't see it unless I paste it on the screen. So, looking for... Ooh, what do we want to do? 1 plus tan over 1 minus tan. Oh, this is a tough one now. Should I change the tans into sines and cosses? Yeah, I don't think I need the formula book. going to change the tans into sines and coses. So that's 1 plus I, and I'll just write S over C for short, over 1 minus I S over C, sine over cos. And then I'll multiply by cos. So I guess cos theta plus I sine theta. Ah, success. Cos theta minus I sine theta. That's good. That's good. That's good. That's good. Because you have now cos theta plus I sine theta over cos theta, and because sine is an odd function, you're allowed to put the minus in, and then because cos is an even function, doesn't care if there's a minus on the angle. So that would become cos minus theta plus I sine minus theta. And since you're dividing polar forms, you can just subtract the power. So that'll be cos theta minus theta plus I sine theta minus theta. So that becomes cos 2 theta plus I sine 2 theta. So therefore the modulus of z will equal the square root of cos squared 2 theta plus I sine squared 2 theta. And then if you let a equal 2 theta, then this becomes the square root of cos squared a plus sine squared a, which equals square root 1, 1. Alright, that was a good one. I liked that one. How'd you thinking? Alright, now the last one. Okay, so you've got an Argand diagram. And then on it we have the circle. That's an I there. And that's the circle K. So a couple of things happen here. First, Z, you add 3 to it. And then after you add 3 to it, this is multiplication, so the order doesn't matter. Multiplied by 2 if you want to next. So then that becomes Z plus 3 times 2. And then the last thing you do is you multiply by I. So that's 2I Z plus 3. So when you add, that's a translation. And then when you multiply by 2, that expands it. And then when you multiply by I, you rotate it 90 degrees anti-clockwise. So if you add 3 to it, it translates it all by 3. So instead of being here at 0, it'll be over here, the center will be over here at 3, and then at 4 and at 2. So that's the first thing done, translation. And then you multiply by 2, so you expand it. So this would be over at 6 then, it's going to be off the page. And then that would be at 4 then. So it would be a bigger circle then, going from 4 to 8. And then lastly, rotate it 90 degrees. So it's going to be right up here. I just put that as 8, that is 6. I know it's not exactly to scale. That's 4. So you rotate it 90 degrees, so I'll put it in green or something. It'd be up here, I believe. So it'd be like that. So that's the image. So it gets mapped like that. So the circle is a unit circle at the origin, and then it becomes this circle of radius 2 located at 6 on the imaginary axis. I think I got that right. Move it to the right. All the points get doubled, and then rotate it 90 degrees anti-clockwise. Hopefully I did those 3 manipulations correctly. Move it to the right, then it expands, and then rotates. Yep. Okay. Okay.